Alright, so we're going to start with 12 and then go on to 3. So we've got a steel wire of this long, stretches this many centimeters. Ooh. Should we change the meters to centimeters or the centimeters to meters? Centimeters to meters, yeah. When it is subjected to a tension of this many newtons. And they want to know what is the spring constant of the wire. So, back here we have a written Y. So, we'll do a little typing. Get my keyboard.
This is number 12.
This is number 12. Number 12. Alright, so the more force applied to the wire, which is acting like a spring, the further it will stretch. The spring constant describes is due to the physical aspects of the wire, but controls the stretch and applied force relationship. I mean, this problem is so kind of, I don't want to say basic, but in a sense, basic, it's really, hey, you know, this is Coulomb's law when it comes down to it, so. You know, so your Y is going to be very basic. Good on the wire question? Let's go on down to our how here. And I want to start with some of those valid equations. So I should grab my equation sheet. And I should grab my Coulomb's law, Hooke's law. I've been doing Coulomb's law all morning. Grab my Hooke's law here. And why it's not pasting, I don't know. Come on. Oh, don't start doing that stuff. Alright, so we grab Hooke's law here. And remember, Hooke's law is relating the amount of force applied or created by the spring to the spring constant, that physical representation, and the change in length of the spring. So we're asked here about, we're given it stretches this far and that much tension. We just need to make sure we convert that 15 centimeters into meters. So going back here, bring that back. So I forget what my numbers were now. 4.4. Really? And I'm dropping the negative, because remember that negative is just indicating that force and that displacement are in opposite directions. And 0.15 meters. Yay! Done.
Wait, is that K or negative K?
Hey.
Just K.
Remember, because I I just said? That the negative only shows that the force and the displacement, the stretch, are in opposite directions. Alright, on to number 3. So you've got two identical charges, repulsive force, obviously because they're identical, and we know that lights repel of this. When the separation is this, what is the magnitude of each charge? Alright, so right here we have our written y again. Since we're going to say that, let's see, since what do they call them? Do they call them particles or charges? Charges. Since the charges, it seems stupid, have a charge about the same charge, the same type and amount of charge, they will repel each other, since all objects that have charge create a force pair with all other objects that have charge. The more charge, or the closer the objects are together, the greater the amount of force. I think I hit everything. Understand the physics? Gonna do some how? Good? Alright. Let's grab an equation. Since it's charged objects that are interacting with each other, it's going to be an electrostatic force. We're going to grab our equation for electrostatic forces. There we go. Which is this one right here. And then it tells me what that force is, 2.2 newtons. Should I keep it in newtons? Yep. They also tell me separation is 1.7 meters. Should I keep that in meters? Yep. Because the Coulomb's constant, they give me 8.99 times 10 to the 9th Newton meter squared per Coulomb squared. So good. So everything is in our base units. I don't have to worry about that. So let's just substitute in now. Of course, remember the numbers is good. 2.2 and 1.7. So, anybody have a favorite color today?
Red.
You got it. 2.2 newtons equals my K, which they give me as 8.99 times 10. Ooh, that's horrible, times 10. Oh, that's right, I just reopened this, didn't I? Times 10 to the 9th Newton meter squared Coulomb squared times 1.7 meters squared on the bottom. Up top, Q times Q, which is Q squared. Solve for Q. Alright, so we're looking at problem number 1 now. You've got a system of, for me it's 55 electrons and 45 protons. They want to know, is the total charge positive or negative, and what is the total charge on the system? Alright, so I have a written Y. So let's see. How about protons have positive type of charge. Electrons have negative type of charge. These two types of charges are opposite each other. The net charge is the total charge on the system due to all the charges combined. That hits everything. I've changed the spacing of my lines. You know, quite now. Make sense? So there really isn't any equation on our equation sheet for this. I'm going to grab this just so I can see it easier. You may see that charge they have on E there. Oh, there it is. Oh, I did twice. Sometimes you'll see that as like 1.602 rather than just 1.6. All right. Just how many six are you going to do? So they want to know the net charge. So the net charge would be the charge because there's electrons plus the charge because there's protons. That would give us a total charge. Does that make sense? The charge because there's electrons would be the number of electrons, we call that density, times the charge on each electron, which is negative E, plus the total charge of the protons would be the number of protons times positive E, and that would give us our total or net charge. I could use like sigma Q over there. So now it's really, this is, I'm going to factor here and get negative NE plus NP times E equals Q total. So I just factored that E out. So now I just put in my 55 and my 45. One thing I could have addressed in my line, I probably should have, is I'm just looking at the numbers. Is it going to be a positive or negative net charge? Negative, because I have more electrons than protons. I have 10 extra electrons. So I could actually, if you look at that, I can do it this way, because I have negative 55 plus 45, that's negative 10. Negative 10 times E is my total charge. I think you did that in chemistry a lot. You know, you had, oh, they were called ions, I think. You know, you had something with a +1 charge because it had one less electron than the number of protons it had, or a negative ion. has more electrons than protons. I know you did that. Chemistry teachers ratted you out, they told me.